Hi everybody. In this video we have a couple of advanced problems involving circles. So here we just have 3 points on the outside edge of a circle. Now to remind you of the equation of a circle, it's down here at the bottom. You'll see why I wrote it at the bottom of the screen in a moment. But it's x minus h quantity squared plus y minus k quantity squared equals r squared, where h and k are the coordinates of a point and r is the radius. Now the problem here is that these points are not special in any way. They're not endpoints of a diameter, so there's no way to get the radius. At least there's no obvious way to get the radius. So we're not really going to think about this geometrically. Rather, we're going to think about this algebraically. Let's just pick one of these points. We have negative 13, 12. Well, if this point is on the circle, it means if I plug negative 13 in for x and 12 in for y, then I'll get a true statement. So if I plug in x equals negative 13, so negative 13 minus h quantity squared plus 12 minus k quantity squared equals r squared, then this sentence has to be true. And the idea in solving this problem is if I were to do the same thing with the point negative 310, I'd get a true sentence, I'd get a true equation. And if I did the same thing with negative 312, I would also get a true equation. So I would have 3 equations with 3 variables, h, k, and r, taking the place of variables, even though typically when I think about this equation, x and y are the variables and h, k, r are just parameters telling me things about the circle. Now it is possible to solve a system of equations like that by hand. It is not a lot of fun, so we're going to use the calculator. So to solve a system of equations in the calculator, menu, algebra, solve system of equations, and this is not a linear system. You cannot choose option 2. This is a quadratic system. So we solve system of equations. I have 3 equations, and since your calculator will support it, go ahead and change the variable names to h, k, and r. There's no reason what we see shouldn't match what we write. And then the calculator has this really nice template where you can just type your equations. We have negative 13 minus h quantity squared plus 12 minus k quantity squared equals r squared. Now, do the same thing with the other points. Now I've forgotten what they are, so I'll have to tab over. Let's see, we have negative 3, 10. Negative 3, 10. So, negative 3 minus h quantity squared plus 10 minus k quantity squared equals r squared. And I believe the last point was negative 3, 12. Negative 3 minus h quantity squared plus 12 minus k quantity squared equals r squared. Press enter, and we have 2 possible solution sets. We have r is negative root 26, h is negative 8, k is 11, so that's one solution. It's like an RHK point, a triple at least. And the second one is the one we want because r is a positive number. So to write this down, because we'll need that to write the equation of a circle, the radius is the square root of 26, and the center is at HK, which is negative 8, 11. So if we go back to the problem, we can write the equation of the circle. It's, turn my pen on please. Let's see, this is x minus negative 8, that makes x plus 8, y minus 11 equals r squared. Root 26 squared is just 26. So that's how you find the equation of a circle given 3 points. Doing the algebra by hand, it's possible, it's not very interesting, so we'll do it in the calculator. Now, next up is another slightly more advanced example. Here, we want to solve each system of equations. Well, what does this have to do with circles? If you look at this top equation, we have x squared plus y squared. That means this is going to be the equation of a circle. We've done this in class, where if you complete the square twice, you can write this equation in standard form. Now, we're not going to do that here because we'd have to undo it anyway. So we have the equation of a circle, and then the equation of a line. So we're looking for where a line and a circle intersect each other. So this is very much a geometry problem. But it's also an algebra problem because we're going to solve the system using the substitution method that you learned in Algebra 1. So the first step in the substitution method is to solve one of the equations for one of the variables. It does not matter which. I would solve the second equation for x. That's easy because it's one step. So we have x equals negative 2y minus 3. Now we take x equals negative 2y minus 3 and we plug that into the other equation everywhere we see an x. So we have negative 2y minus 3 quantity squared plus y squared plus 2 times negative 2y minus 3 plus 47y plus 147 equals 0. And, well, we take as many algebra steps as we need. The most common place to make a mistake is here when evaluating this square. If you need to, write negative 2y minus 3 times negative 2y minus 3, so you can use the distributive property and not mess up. So this is going to be positive 4y squared, and if you use the distributive property, let's see, we're going to have a plus 6y plus another 6y, so that's going to be plus 12y, and then negative 3 times negative 3, we're going to have plus 9. Now I'll continue writing, plus y squared, use the distributive property again here, minus 4y minus 6 plus 47y plus 147 equals 0. Now, let's group some like terms. Now, I'm not doing this for the benefit of a YouTube video. There are lots of terms here. It would be very easy to let one slip by, so I'm going to be very careful and color code these and underline these. Do whatever you have to do to not let one slip through. So we have the y squareds, we have some y's, and then I'm not going to underline the constant terms. Everything that's left is a constant term. So if I combine everything we have, this would be 5y squared. And now for the y's, we have 12 minus 4, that's 8. And then 47 plus 8 is plus 55, so plus 55y. I like that both of these are multiples of 5. And then we have 9 minus 6 is 3. 3 plus 147 is 150. So I think I'm on the right track. A computer program is designing nice math problems. Everything being a multiple of 5 is a good sign. So I'm going to divide everything by 5. We have y squared plus 11y plus, let's see, 150 divided by 5 sounds like 30. All right, now we're down to just a quadratic equation, and we can solve this by factoring. So we have y plus 5 times y plus 6. So we have two possible y values, y equals negative 5 and y equals negative 6. Now, remember what we're doing in this problem. We're solving a system of equations. We're looking for where two graphs intersect. So our solution isn't just going to be a y value, it's going to be a point, an xy point, because that's where two graphs intersect in 3 dimensions. All I have are the y values. So if I want the x values, I need to plug this y value in somewhere. Now the easiest place to plug that in would be right here. So I'm going to take y equals negative 5 negative 2 times y, so negative 2 times negative 5 minus 3. So that would be 10 minus 3 is 7. That gives me an xy point. X equals 7, y equals negative 5. Now, for the other point, let me pick a new color. We'll take y equals negative 6 and also plug that in. So x equals negative 2 times negative 6 minus 3. That's 12 minus 3. 12 minus 3 is 9. So our other point of intersection is 9, negative 6. So here's one place where the two graphs intersect each other, and here's another. Just don't forget the big idea of what we were doing here. We had the equation of a circle. We had the equation of a line. So we found two places where those intersected. And it would be possible, given a system like this one, let's say the line looked like this, it'd be possible that there'd be no solution, they don't intersect at all. And it would be possible to have a tangent line that only touched at a single point. But anyway, we found 2 points of intersection, which means we're done. So, hope this video helped.